This is my first video on stem and leaf plots, and after watching this you should be able to construct your own stem and leaf plots, but also interpret the data that we place in them. Okay, so let's go ahead and start by defining what the heck a stem and leaf plot is. We say a stem and leaf plot is a data plot that uses part of the data value as the stem and the other part of the data value as the leaf to form groups or classes. So we're really creating basically a distribution here of data, but doing it in such a way that it's a little bit easier to read. So stem and leaf plots, and actually it seems that I pasted in the same thing here, so ignore this. We say in order to construct one of these, what we're going to do is this. We're essentially going to arrange the data in order from smallest to largest, and that's the most appropriate way to do it. I've seen people do it without doing that, but I think it's a necessity if you're asking me. But what we're going to do is we're going to separate the data according to the first digit. Now the first digit, when we talk about a number here, for instance, say the number 32, the first digit in this number is the 3. Okay, so what we're going to do is we're going to give this a name. We call it the leading digit, or the lead digit. Okay, and we're going to separate this from everything else that trails off after it, but we say everything after this would be in the leaf. Okay, so we say the leading digit, it belongs in the stem. We say a display needs to be made using the leading digit as the stem, and we say the trailing digit as the leaf. So everything to the right of the leading digit, we're going to refer to this as the trailing digit. Okay, or in this case we have only one digit, but we could have trailing digits as well. That's certainly a possibility. Okay. So here we have a situation where if we had the number 32, 3 would be in the stem because it's our leading digit, and then 2 would be the trailing digit, it would be in the leaf. Okay, so I'm just basically going to construct one of these over here, and we'll take a look at what it looks like. But we say an outpatient testing center, the number of cardiograms performed each day for 20 days is shown. Let's construct a stem and leaf plot for the data. So you'll notice first of all that our data is not in order, and that's the first thing I do want to do. It seems that we have, let's see here, 2 rows of 10 data. That means we have 20 total data. Let's put this in order where our first datum would be a 2. So we say 2, put a comma here. There are no other digits in the single digits, so we're going to climb up into the teens here, and it looks like I think 13 is my next smallest datum, but we say 13, so we get 13. 14 lives right next door to the 13, so I'm going to cross those off here. Any others in the teens? I don't see anything that start with a 1. Let's look at numbers that start with a 2. So I say 23. Is there anything smaller than 23? And 20. As a matter of fact, we have 20. So we say 20. Cross 20 off. Are there any other 20s? I don't see any other 20s. It looks like our next value here would be 23, and then we'd have 25. So we have 23, 25. So we'll cross those off here. And now I have no other values in the 20s. Let's kick it up to the 30s. So do I see a 30? I don't have a 30 here, but I do see a 31. So 31, we'll write it down. We'll cross it off here. Do I have any other 31s? I don't have any other 31s, but I do have, let's see here, 1, 2, 3 30s, 2. So we say 32, 32, 32. So we'll cross those off. As a matter of fact, I've missed a 32 right there. We have 4 32s, and we cross those off. Do I have any other 30s? Well, there's a 33 here, 33, and then 36, 36. And then we say, okay, so now that I'm out of the 30s, let's look at the 40s here. It looks like we have a 43 is our smallest datum in the 40s. So we say 43, cross it off. Looks like we have a 44 and a 44, so 2 40s, 4. So we say 44, 44. I'm going to try to make all this fit here. And then we get a 45. I'm going to have to actually bring that down over here. I hope nobody minds. And then we say, okay, so in the 50s, it looks like we have a 51, 52, 57. So 51, 52, and 57. And now I would strongly encourage everybody, when you do something like this, to count up the data that you had. Just make sure you have everybody here. So I have 4 in this bottom row. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So these are our 20 data. Now, when we make a stem and leaf plot, we're going to start by making the central stem, okay? And so I'm gonna label this here. We call this the stem. And what we're going to do is we're going to put the leading digits in this column. But when we talk about the leading digit, recall that in the case of 32, we said 3 is this leading digit, and everything after that is our trailing stuff. But in each of these instances, for instance, every number in the teens here, it has a lead digit of 1. Every number in the 20s has a lead digit of 2. And every number in the 30s has a lead digit of 3, okay? So what we're going to do is we're going to put our leading digits out here. The one I want to comment on is this, the 2. Since it's in the single digits, technically, since I want to make this have the same place values as every other value that I have in my data set, I technically need to include a value in the tens spot, so we're going to put in a 0. So we say our stem includes these values, 0, so our single digit numbers, numbers, our teens, our 20s, our 30s, our 40s, and we stopped when we got to a leading digit of 5 here. So now in the leaf, okay, we're going to call this the leaf part, okay, or the leaves. But basically, what we're doing is we're going and we're placing all of the trailing digits to the right of this. Now, it's important, I think at least, to line these up to a certain extent, but I noticed that what are our values in the single digit section of this, or the single digit row of our stem and leaf plot? We'd say that 2. 2 is a value. So when you read this, what this communicates to your audience is that I have one value in the single digits and it was a 2. When we get into now 13 and 14, we would say that 13, we would put a 1, 3, and a 14, I'd put a 1, 4. So this will account for our 13 and our 14, and you can see that I have 2 data values in the teens, but only 1 data value in the single digits here. As far as 20s, we had 2, 0, so we say 20, 2, 0, 2, 3, so 23, and then 2, 5, 25. So you can see that there are more values in the 20s that there are in the teens, and there are more values in the teens that there are in the single digits. This really is a distribution where formerly we were making classes and then putting tally marks. The nice thing about this data set is it's kind of like telling you how many values live in each of these neighborhoods here with the leading digits, but also exactly what they are. For instance, 20, 23, and 25. So now let's go ahead and finish this up. We say 30, we got 31. 1, 2, 3, 4 30s 2, so we say 2, 2, 2, and 2. You notice that I'm lining these up here. That's an appropriate thing to do. We also had a 33, so a 3, and a 36, so 36. And we say 43, so I'll put a 4 and a 3. And we have 2 40s 4, so we say 44, 44, 45, and then 51, 52, and 57. Okay, so you can see how the stem and leaf plot works here. This isn't really a leaf, but I suppose we could kind of like use our imagination there. There's our leaf, and this is the stem, maybe, okay? Kind of looks like a flag. But what I can do is I can actually draw conclusions from this. We say, okay, well, what set of values had the most values in it, or what neighborhood had the most values in it? We say most of our outpatient cardiogram numbers are somewhere in the 30s most of the time if I'm reading this data here. And I could also say things like, well, there's a mode. We say the mode of this data set is 32. It occurred more than any other thing. Okay, but really what this allows us to do is to see where the data lives, but not only see where it lives, but exactly what the data values equal without having to write the data in a raw data fashion. Cheers.